is our sixth example of the quotient rule. In this example, once again, we're going to have just a lot of stuff going on. We're looking at a quotient rule. We're looking at a product rule. We're looking at a derivative for a constant. We're also looking at notation here. This is displacement notation. And so when I take a derivative, I say s prime of t, but that s prime of t eventually becomes just v of t because the derivative of displacement is velocity. And so let's start off with our calculus here. We're going to start off with a quotient rule. Quotient rule says low d high, derivative of the top is 2t minus 3, minus high d low, derivative of t is just 1, over the denominator squared. And then as I move to my second set of terms here, this is going to be a product rule. So I do u dv, the derivative of the second part is 3t plus 1 quantity squared, plus v, which is t plus 1 quantity cubed, times du, derivative of 5t is just 5. And finally, the derivative of our constant is just 0, so it dropped out. And then obviously, there's some work that needs to be done here. First thing I'm going to do is expand this. I'm going to FOIL this thing out here. And so when I FOIL it out, I get 2t squared minus t minus 3. And then my next step is to distribute this negative across here. So that produces negative t squared plus 3t minus 5. All over that t plus 1 quantity squared. And then from the second set of terms, I notice that they have a great similarity here. So I'm going to pull out a t plus 1 quantity squared, and I'm going to pull out a 5. And that's what we see right here, 5 times t plus 1 quantity squared. From the first set of terms in this section, that would leave me with a 3t, because the 5 was pulled out, the t plus 1 quantity squared was pulled out. That left me with 3 times this t. That's my 3t right there. And it left me with a factor of t plus 1. Now with that factor of t plus 1 being added to the 3t, obviously I can combine that together. And you see that's where I get my 4t plus 1 here. I have my 5 times t plus 1 quantity squared. That's what was there. And then from this original numerator, I was able to combine all those like terms. 2t squared minus t squared was t squared. Negative t plus 3t was positive 2t. A negative 3, a negative 5 was negative 8. And then for the most part, that's where I left it. I guess you could, if you wanted to, you go a little bit further. You could multiply this entire set of terms by t plus 1 quantity squared on the top and the bottom if you wanted to join that together as one fraction. I was okay with it like that. A lot of times it's just a matter of preference, how you're going to use it, what you're going to do with your derivative. If I'm just plugging a value in, I don't see the merit in turning this into one big fraction. It's going to take more time than what it's actually worth, particularly if I'm plugging a value in for t, like if I'm plugging a 5 in, I can easily plug it in where it is right now. Okay, so that was our sixth example for the quotient rule.